Okay. So essentially, I'm an orthopedic surgeon. I'm not a programmer. I sort of do use programming for some of my utilities, because as well as being an orthopedic surgeon, I am a faculty and founder of Chaos UK, which is computer-assisted orthopedic surgeons of United Kingdom. I have an interest in tissue engineering, electronics, robotics, and programming. And these are sort of like a side job for me, because my main job is actually a surgeon. But they're sort of, I'll tell you why this is important for me. Yeah. So I'll describe my talk into a few sections. I'll give you a context of what I'm trying to do in my projects, and I have a couple going. I'll talk about the actual quick and dirty GUI. That'll have the bulk of the talk. I may briefly talk about simple, which is allowing the end user to be a developer as well as then I'll use this opportunity to get on my soapbox and give you a couple of slides on why I think the world is going horribly wrong. Only 2 slides. It won't be time. Yeah, I'm sure we won't have time. So basically, one of my interests is tissue engineering. So basically, just for a potted understanding of tissue engineering, organisms are made of cells. Cells are supported by matrix. They're nourished by a blood supply. So technically speaking, you could take a bunch of cells, take a sponge made of plastic, which is biodegradable, and give it a blood supply, and you've suddenly got a living construct. Yeah? This is a nude mouse. A nude mouse is nude, but also peculiar to it, it does not reject anything you put into it. It doesn't have a natural rejection mechanism. So you can take a bit of plastic, the shape of an ear, soak it in some human cartilage cells, and then put it in the back of a mouse, and that mouse will nourish that construct for you, and you end up with an ear. This is a classic experiment. I'm sure you've come across in your travels, done by a guy called Vacanti in North America. Essentially, he used to say that once they've made this mouse, they could never catch him ever again, because he could hear them a long time before he got to them. So tissue engineering, how other people do it, we want to try and create organs, not just bits of tissue. We want to create organs, and the organs are made of lots of different tissues, spread in different areas, and they have a structure which is more than just a shape. They have the structure which is related to their function. So we can try and 3D print these constructs. You can 3D print a biological construct, yeah? And they can be, the cells can be distributed in geographically distinct places according to their function. So these are bioprinters. Very few of them actually work, but they are concepts which are available. They're horrendously expensive as well. And I work in a small lab 1 day a week. And it's difficult for my lab to afford these kind of structures. So we thought we'd build our own. And we decided rather than have a unique method, most printers work on XYZ axis. You have an XYZ axis, and then you build up a construct. So we devised a polar geometry to allow us to build a construct, living construct, inside a small cavity. And that requires quite a different idea. It's an open source device, so you can have access to all the designs, the hardware, and everything else. And it's actually printed in a 3D printer. Whereas those 3D printers cost several tens of thousands of pounds, this one can be built for around about £100. And the idea was that I would try and build this and then deliver it to my colleagues who are also tissue engineers and biologists. But the trouble is, none of them, I have to be able to deliver to them in a way that they can actually be impressed. Nobody's going to want to spin up a command line interface every time they want to try and pass a file of 3D coordinates into the system. Yeah? This program that I have to develop, and as I remind you, I'm not a natural programmer, it has to be usable by somebody else. It has to be usable by someone who is not a programmer as well, who needs to be able, we need to be able to abstract the complexities of the machine and deliver it in some way an ordinary user, or a clever user maybe, someone who is a scientist or a doctor or an engineer can use it. So these things should be possible to do in an interface that they're familiar with, a desktop interface. Yeah. So and for 3D development, visualization is critical. Yeah. It's very difficult to convert a set of coordinates into an image in your brain. So you have to represent it visually. You have to represent the motions of the motor, the construct you're building. It needs to be visualized. And once you have that device made, for it to work, you need to be able to also manipulate. It shouldn't be just there to produce one product. Yeah, you should be able. The end user must be able to choose for himself what he wants to do with the product that he produced. I'm going to focus on two components. I'm going to focus on the need to visualize the visual thing and make a program accessible for non-programmers. Of course, this would mean that I have to learn a lot of other clever things if I'm going to do it all in Perl. Yeah? But I'm rather old. My brain doesn't quite function quite as agilely as most of you guys, and so I try to find my own way of trying to do this, and I've diverted into trying to develop a way of generating a graphical user interface for my application, which I've written in Perl, because that's sadly the only language I do know. I'm not very well at that. So essentially, what was this? So it is possible to make Perl GUI applications. Lots of toolkits exist. WX, supposedly multi-platform. Qt is not easily installable from CPAN, I don't think anymore. GTK is actually not too difficult. Windows applications, I don't have Windows machines, but Windows will have their own Perl toolkit backend. TK is obviously the most ubiquitous of Perl users, but it's got dated looks, people don't like it. And there are clever toolkits that you can use, WX Glade and Qt Designer, all adding to the things that I have to learn to try and develop an interface that I will do. And there are problems associated with that. It's not as easy as it should be. At least I haven't found it that way. Lots of systems can't install WX. And it's interesting that Qt5, which depends on Perl to build it, does not provide an API for Perl. You have to use Qt4. Yeah. TK works, but people complain that it looks old-fashioned and dated. One of the most peculiar things I saw for trying to develop a Perl GUI was to use Inline Python to do that. And I thought that's a paradox. And currently, if I look for interface development ideas, then it's very hard to find, and often the data is quite old and outdated. So it's too much effort for me. Yeah, there's too many toolkits, and it is likely the toolkit that I find will work on my system will not work on my colleague's system. There's too many paradigms. Each of those toolkits have a different way of interacting with the back end. And really, it is far too complicated for me. And even if I get it to work on my desktop, I'm not likely to get it to work on somebody else's desktop. So this is the thing, you see. What happens is we have such a diverse set of platforms to work on and interfaces to make. It makes it easy just to avoid the work desktop. Let's all use a browser as our interface. Everybody's got a browser. Everything will be done on the server side, and you'll have a little web server delivering the product. It's just. And it seemed to me for my projects rather limiting. So I'll describe how I did it. And it's not probably the best way of doing things. It's just one way, and there's lots of ways of doing things. It may not work for everybody. And certainly my coding skills are not very great. They're quite rubbish. And I'm happy for anybody to constructively criticize what I do. But there are reasons I did it this way. I have a full-time job. I can only code for a certain amount of time. I can't learn new things. For me to write 10 lines of code requires 20 visits to Stack Overflow and things like that. So, and other people need to be able to read my code. And I need my application to be used by people who don't code. So I can create a graphical user interface on a piece of paper. I can draw a picture of the interface. It's got things like a picture images, it's got a title, it's got labels in there, buttons in there. And I want to be able to do it in a way that I can visualize. But I don't want to use a tool. I don't want to use WXGlade or Qt Designer because they're another thing for me to learn. And I want my GUI interface to be agnostic. It doesn't care what operating system you use, whether you have one particular backend available and you can't install another one. I need to be agnostic. And I wanted to go from a drawing to a desktop application. Now you can design your own desktop application on a text editor. So here is something that looks like an application. You can have a title bar, you can have buttons in there, you can get little text areas, image areas, you can have other bits of data that you can manipulate, texts that can be changed. And this is just a text string. And Perl is good at parsing textual data. It can take that string and convert it into something else. So this was birth of GUI De Fate or GUI De Fate. I don't know. It's the world's simplest GUI designer. He just takes that string. It takes that string and identifies within the string the widgets that are identifiable. Yeah, and it puts them into an array. It creates an object which has which connects to a backend, whichever backend you've got. You've got a backend which can handle TK. You can have a backend which may handle GTK, WX, Win32. That whatever backend you can get to work on your system, it will create that interface for you, and you'll build up for those widgets in that interface. And if you look at the idea is that text string, you've already decided where your buttons are going to go. So you can calculate from that text string where the buttons should go in the final application. I'd make it simple. There's only a limit. The more complicated you make it, the more difficult it is. I want it to have very few widgets. It needed to be, because it's more useful that I can run it on other platforms. And I want that interface to be visible in the program code. I don't want to have another separate file, although you can. You can have a separate file. I want that widget to be in my code. And it is programmed, sadly, by someone who is an amateur. It is programmed by someone who just cut and paste little bits of code from other places on websites and tried to make something together. So here it is. I mean, this is how it works. So you use GUI De Fate. You create a string that represents your textual idea of your thing, and you use GUI De Fate to convert that to a window. And you start the main loop. A GUI interface, I have discovered, requires is a loop, a looping application, and all of them have a little main loop. So, and you can generate a a little desktop application that does that. Looking at this, you can tell what this. Looking at the string, you can tell what it's going to look like. And it tries to match that. It supports multiple backends, including Win32 and WX, and even the web. You can create a web application without having to have Modulicious or Dance or anything else like that. So, so there's only one object, the graphical user interface frame. Yeah, the GUI De Fate PM. What it does, extracts the widgets, puts them into that object, inserts the widgets that it finds into an object. They're sequential, it's an array, and each object can be accessed by functions that you return. And that the GFWX object has ability to access any of those widgets that you have. You can choose a backend. So by changing a couple of letters in your code, you can convert an application which is designed for TK to work in GTK or as a web application. And you just invoke it this way. You pass it a string, you pass the backend you want, and any assistance you might need. So what kind of assistance might you need? You might want to know, how do I access the buttons? It'll create, if you like, if you want, a list of functions, subroutine code that you can insert that allow you to access these things. Yeah? So let's have a look. This is how you invoke a new window is a string that contains a textual representation. The backend could be WHDA, etc. An assist, for instance, this is a verbose output. It tells you that it's discovered in your creation of that interface a button with label draw, and it gives it and creates a function. That draw button, that widget, on activation will call a certain function, they're all sequentially numbered as it finds them. So you can auto-generate the code if you want as well, to generate the code that will apply it. So this is all done without using any other toolkit interface. So here it is. Here is a calculator that looks like a calculator when you design it, and when you transform it into a WX, GTK, TK, or I can't remember what that one is, or something else. QT. They all look roughly similar. So, and it works. They all interact reasonably well. So I didn't have to know any of the backend specific. It's all abstracted away in the GUI De Fate modules, submodules. And you can create only a few things. You can create back again. How do I go back? Oh dear. How do I just go back again? Sorry. So, sorry about that, guys. Essentially, what I have managed a few. Oh dear. Let's do it this way. Yes, my network has gone. Yeah, let's try the PDF version. That might work. Yep. There you go. Function F11. Okay. Marvelous. Okay, sorry about that, guys. Yeah. So a few things you can do. You can have buttons, input boxes, combo boxes. And because it's a string, you can actually programmatically create that interface. You can insert into that the parameters that you want. The image box is just an image box with the path of the image inside. So you can it automatically finds the image that it refers to, the text area. You can insert the content that you want, the default values in that text area as well. Yeah, sorry about that, guys. For example, this is another application which was my attempt at trying to create end-user programmability. So I created a program that does there's a logo, produces a logo script. So it interprets this string over here, this string of data that's entered in a text area, and allows me to create an image from that string. You can create a simple string, a simple game. My rock, paper, lizard, Spock, scissors. Yeah. So you, this will work in any application, even across the web. Yeah. I've highlighted these text strings just to make it easier, but you can see which ones are buttons by the curly braces. Obviously, this is crude. This is crude because if you have my skills are not that great, and if you have curly braces elsewhere, it'll imagine in your text that you want to put in, then obviously it'll interpret them as buttons somewhere else, and you can't have curly braces in your label itself. You could, but then it wouldn't look so neat. If I put escape characters over here, then it wouldn't look as if the visual aspect will disappear. So yeah, you could, and certainly there has been suggestion that I could use other UTF special characters that allow me to make it look more visual. But then it stops being easy to create on an ordinary on a notepad, for instance. So, and you can create applications that load other applications, and you can even convert this into a web application. So basically, I can run this as a web application. I can just and all I have done is to go from a TK application to web application is replace the two characters TK into web, and it produces a little web application for me that will allow me to interact with it with buttons as well. What it does is it allows you to do things useful into something usable. For instance, GNU plot, very useful application. It's a command line, and there isn't many GUI interfaces, at least in Perl for them. There are, I'm sure. But here you can do it in a few lines of code. In less than 100 lines of code, you can create a graphical application that allows your GNU plot to work. Image Magic, a huge application with over 156 functions in there, and to know that, to use that in your application, the interface is not straightforward, and I can search on the internet a table of functions for GNU plot. Yeah, and I can convert that by using your Perl superpowers into something that will convert that into a menu that allows me to access all of these functions and allows me to do the manipulation that I want that Image Magic can do easily. You can even duct tape the internet to the desktop. Yeah. Here's an application that we saw earlier in the design process. Here's an app. It's an application, and I've got no interest in plants really, but I thought somebody challenged me to do it, so I did it. Essentially, what could be done is that there's a website called plantslist.org. It lists all the plants in the world. There's also something called Wikipedia that contains lots of information about these things. So I can go and search the millions of plants that are recorded in the plantslist.org, and I can search for them. I can search for asparagus. It will search plantslist.org. Having extracted the key parameters by using some regular expression to extract from the web page that it demonstrates, I can extract the group, the family, and the genus, and by putting the family and the genus into Wikipedia, I can see if there's any pictures of that item. So I've stuck together two websites and presented them on my desktop as a desktop application. So what has that got to do with me? I mean, doing this working through a desktop transforms your workflow. It gives you immediate visual feedbacks of your yields. Yeah. And it frees up programming time. The time that you spend trying to get your interface to work, all that is gone, and it makes simple applications you make available to general user. And the thing about it is, the web currently for Perl developers, the main interface to the non-Perl programmer is through a web application, and it unnecessarily narrows the scope of the user. And niches that are not exploited can be taken over by anybody else. So I'm also interested in end-user programmability. So there is a little module that I've also created, which is to allow my programs to be programmed by other people, by ordinary people. And here this GUI De Fate allows me to do that. It allows me to allow a program and have the user have a feedback on that side. And what that means is if I can script a program, I can script a program to create the script that creates the output. So basically, what I want to do is to enable me to control my robotic device, I need to be able to generate a script that describes the motion of the robots. And I need to be able to visualize that. So this allows me to create scripts that generate an output, and I can visualize that output. And that's the thing about Perl. Perl allows you to make those script parsing very easy. Now, sadly for my soapbox. So there are two things that are attributed, I think, to His Holiness Larry Wall. The goal of Perl is to make easy things easy and to make hard things possible. And he said also, the power of the programming language is not what it lets you do, but what it lets you do easily. And I will take those statements and come to a conclusion about this. So when I was a kid, long before most of you were born, I had a ZX Spectrum. You coded that with a pencil. The only IDE that you had was a pencil. You wrote your own assembler in BASIC, and then you programmed your assembly code on that. One of the first books that I read about computing was this book, Dr. Ian Logan's Spectrum ROM Disassembly. Sounds like a riveting read, but I'll tell you, it is fascinating. It is fascinating in the sense that how somebody clever was able to condense a language and an operating system and an interpreter all into 8 kilobytes of RAM of Z80 code, and that allowed. And what happens when you have these languages, when you have this platform, you learn the intricacies of the platform. You learn to code it. You learn the inside of it, and then that platform becomes obsolete. There's no need for me to code it in Z80 anymore, and I never really understood GFA Basic either. But Perl seemed different because it was so portable. It's so comprehensive, and it seemed to have lots of superpowers. Yeah. So it's got CPAN modules for everything you want to do. It's got super text processing. It's supposed to be performant, and you can do more with less in Perl. And Perl is powerful. It can serve so many people behind other interfaces, web apps, websites, server management, all these things. And because it's low maintenance, because it is robust, it is invisible. Nobody notices. And that's the thing about it. If you have powers which are invisible, it vanishes, and no one notices because it was invisible to begin with. Because what happens is other tools, less powerful, which are visible, take over the functions that you could do before. So I would suggest that we need to make applications visible. We need to use a GUI. It makes your application accessible for other people. It makes it useful. It makes it intuitive. Yeah? And you need to make it unconstrained. You don't have to use GUI De Fate. You can use your cleverer guys, so you can make things better. But powerful Perl applications already exist. Slices, what I use for my 3D convert to generate for 3D printing, is in Perl. Frozen, but there are not many GUI applications. And one of the sad things was the last Perl GUI application in the Linux desktop was screenshot, and that's been taken off. The last Perl application is no longer in the basic install of a Linux distribution. So I would say, from those things that we discussed, it is not enough to make hard things possible. Hard things should be made easy too, and that's what that's the paradox. That's the message I would like to say. And it's not enough. A lot of us, well, I have done up till now, create programs to serve my needs. But the program that we develop should be for anybody to use to get the result that you want. And the thing about it is when we focus on the niche applications, we give up on a methodology purely because it's too difficult. Then what happens is other things, other applications, other paradigms fill that void, and you've lost it. You've lost the void. So yeah, that's my talk over. Do we have time? No, sorry, I overran. I do apologize. So, but yeah, that was my talk over. Thank you.